Hello and welcome to September 25th, 2013, the live meeting. I was asked to work this problem. It's for 2.6 number 8 from WebAssign, 2.6 number 23 from the book. So the book problem is going to be slightly different at the point where we talk about how the rope is going in and the position of Y, but the rest of the process is the same. So went to the top of a 12-meter building, pulls a pipe of the same length, so the pipe is 12 meters as well, to a vertical position, as shown in the figure. The winch pulls in the rope at a rate of negative 0.1 meters per second, and that makes our DSDT be negative 0.1 meters per second. I put that down here. Find the rate of vertical change and the rate of horizontal change. So the vertical change is going to be our dy dt, and horizontal change is dx dt at the end of the pipe when y equals 2. So we're going to find that particular case when y is 2. Round your answers to 3 decimal places. So I want to start off by, if we just looking at this, the pipe is at some position, and it has a horizontal length and a vertical length. The component that makes it up. It makes a right triangle. And so if x is the distance it is horizontally and y is the distance vertically, x squared plus y squared is 12. That's a relationship through the Pythagorean theorem. And this Pythagorean theorem relationship, or just the Pythagorean theorem relationship, is what is really critical here. And I wanted to ask this question here. If this side is y, how much is this? If the whole thing is 12, how much is this part up here? That whole thing is 12. 12, this is y. That's just going to be 12 minus y. And that comes down, I want to redraw the problem. Here's our pipe. Here's the rope or the cable S that's pulling it up. Again, here's y. Whole thing is 12. So this is 12 minus y. And the x value is still the x value. So this x would be the same as x for the upper one. So in that upper triangle, what we have is the side 12 minus y. It looks like I wrote x there. Let's fix that. 12 minus y. And here's our x, and this is s. So for this part, this triangle has a relationship that 12 minus y squared plus x squared equals s squared. Now if we're going to take the derivative with respect to time of 12 minus y squared plus ddt of x squared equals ddt of s squared, we'd have 2 times 12 minus y times the derivative of what's inside. Well, the derivative of y is negative 1 times dy dt plus the derivative with respect to time of x squared is 2x dx dt equals the derivative with respect to time of s squared is going to be 2s ds dt. Now we can divide everything by 2. Right over here, 2 times 12 minus y times negative 1 dy dt plus 2x dx dt equals 2s ds dt. I just rewrote the problem. Nothing's changed yet. I'm going to divide this part by 2, this by 2, and that by 2. The 2's will divide out. So we have 12 minus y times negative 1 dy dt plus x dx dt equals s ds dt. And it's because this negative 1 is here, let's just distribute it through here, making that negative 1 times 12 is negative 12. Negative 1 times negative y is positive y. So this becomes y minus 12 dy dt plus x dx dt equals s ds dt. Now there was another relationship I had expressed in the beginning, that x squared plus y squared equals 12. So if we take the derivative with respect to time of each of these, the derivative with respect to time of x squared is 2x dx dt, plus the derivative with respect to time of y squared is 2y dy dt, and the derivative with respect to time of 12 is 0. So we get 2x dx dt plus 2y dy dt equals 0. And we can subtract 2y dy dt from both sides. We'll have 2x dx dt equals negative 2y dy dt and dx dt would be equal to, if I divide both sides by 2x, negative 2 and 2 cancel, so we have negative y over x dy dt. Give myself some more room to work here. Okay. Now we can do some substituting. Rewrite what I have. I have y minus 12 dy dt plus x dx dt equals s ds dt. We also have dx dt equals negative y over x dy dt. We could also, if we want to solve for dy dt, multiply by the reciprocal of negative y over x, which means multiplying by negative x over y. So that negative x over y dx dt equals dy dt. Okay, so we have this relationship. We can substitute if we need to. Okay. Now, what if I took, I'm going to go with this first one here. Substitute for dx dt. Dx dt equals negative y over x dy dt. I'm going to put this in place of the dx dt. So we have y minus 12 dy dt plus x times negative y over x dy dt equals s ds dt. So we have y minus 12 dy dt. The x here and the x down below cancel, so we have minus y dy dt equals s ds dt. Now if I distribute, this would be y dy dt, distributing the dy dt, minus 12 dy dt minus y dy dt equals s ds dt. So we have a y dy dt and a minus y dy dt. Now, I think you can see that's going to be minus 12 dy dt equals s ds dt. so that our dy dt is going to be equal to s over negative 12 ds dt. Okay, now what information do we have? Do we have anything about s that'll help us here? It says that find the rate of the vertical change and the horizontal change at the end of the pipe when y equals 2. Okay, so this is going to be a couple steps to get. We know this is 12, we know this is x, and we know this is y, and y is 2. So if y is 2, we'd have x squared plus 2 squared is 12 squared. Or x squared is, or I should say x squared plus 4 is 144. So x squared is 140. So x would be the square root of 140. Now that same x squared is going to be used in this next triangle. If y was 2, 12 minus y was 10. This is square root of 140. And then we have s. So s squared equals 10 squared plus square root of 140 squared. So s squared equals 100 plus 140. So s squared equals 240. So s equals the square root of 240. And our dy dt would be the square root of 240 divided by 12 times ds dt we said was negative 0.1 meters per second. Let me find my handy dandy calculator. Here it is. And the exact value I get here is negative square root of 15 over 30 meters per second, which would be negative 0.129099 meters per second. Okay. Let's check my signs here. Because I think that one's supposed to be positive because it's rising. So I might have a double negative issue somewhere. Okay, the other part was what is a horizontal change? What is our dx dt? Oh, there is the double negative. This is supposed to be negative 12, which makes this positive, makes that positive. Okay, good. So then we want to find our dx dt. And as I found earlier, dx dt is negative y over x dy dt. So that's going to be negative y over x dy dt. It's going to be negative, and our y was 2, and our x we found to be the square root of 140 times dy dt, which is the square root of 15 over 30. And that'll give us what? I have the square root of 21 over 210, which is approximately 0.5 0.021822 meters per second. I think they want us to round to the nearest thousandth, so this would be, by the way, that's negative. I forgot about the negative sign. Negative 0.022 meters per second. Okay, that's what that one would be, and this is for the y. And so if you have a different y value, as it generates different y values, you'll need to work that out a little bit differently, as we saw up here with our Pythagorean theorem there and the Pythagorean theorem here in these two different right triangles. And remember, the upper one is y minus 12 minus y. The lower one is just y. But you get the x from the lower triangle, and then you can get s from the upper triangle. And that'll affect your dy dt, and then that'll affect your dx dt as well. So, hope this helps. Hope it makes sense. I'll talk to you guys later.